All right, let's go ahead and dive into our sex-limited traits. So these are going to be pretty similar to sex-influenced. For our first couple points, they're not on sex chromosomes. They are on autosomal chromosomes. And the place that it's different now, remember, in sex-influenced, it was influenced by a certain sex. In sex-limited, just like the name says, it's limited to a certain sex. So this means either it can only be expressed in males, not in females, or it can only be expressed in females and not in males. But keep in mind, the sex that is not expressing it can still carry the gene and pass the gene on to their children. So if it's only expressed in males, and let's say that it's a dominant A causes curly hair, and that only happens in males. Females can still have a dominant A, but because it isn't expressed in her, she's not going to have curly hair, but she could pass that dominant A onto her son, and her son would use that and have curly hair. So just like sex influence, whenever you're solving, treat it like a dihybrid, where the other trait is XX or XY, because these are the sex of the individual does matter for these, just like it did with sex influence. So the example I have for you here is with tampons. So we know that only females need tampons. Males may go to the store and buy tampons, and they'll carry the tampons around the store, but they're never actually going to use it themselves. And he may take a tampon out of a drawer and pass it on to his daughter. And the daughter is going to use the tampon that she just got from her dad, even though the dad could never use it himself. So going back to our genes, only females express this gene. Males can carry that gene, but they're never going to use it, or AKA, they're never going to express that gene. And a male can pass the gene on to the daughter, and the daughter can express that gene, even though the dad could never express it himself. Let's look at an example. So we have our same cacti example, except now instead of it being sex influenced, it's sex limited. So spikes in cacti are sex limited traits. Spikes are dominant to no spikes, and they are only present in females. A non-spiked female is crossed with a non-spiked homozygous dominant male. Draw the ratio for their children. So in this case, we have spikes are dominant. I'm going to call that big A, and I'll have my little a. So in sex influence, we had to use A and B. You don't have to do that here. Little a is going to be no spikes. And just like with sex influence, I'm going to set it up into just looking at what does a male look like, what does a female look like first, then go into the cross, and then look at the children. So for a female, so spikes are present in female, and they are only present in females, and spikes are dominant. So that means that being big A, little a, or big A, big A, or big A, little a means spikes. And the only way for a female to not have spikes is being little a, because it's recessive. Simple enough. Now let's look at male. And males, spikes are never going to exist, no matter what the genotype is, because spikes are only present in females. So for a male, no matter what their genotype is, they're not going to have spikes because they're not capable of expressing spikes. Okay, now let's look at my cross. I have a non-spiked female. So it's a female, so I go to my female side and I say, okay, where's no spikes? That's little a. And because she is a female, and remember the sex matters here, we treat it like a dihybrid, I'm going to add my XX. And for my male, it says a non-spiked homozygous dominant male. So this is where it can get a little tricky on exams if you're not reading closely. I tell you he's not spiked. If you didn't realize that it was only present in females and you were like, oh, non-spiked, oh, he must be homozygous recessive. And then you saw homozygous dominant, then you might be like, wait, is non-spiked dominant? And you could get really, really confused if you didn't realize that it was a sex-limited trait. So because for males, no matter what genotype he is, he's no spikes, this non-spiked is extra information. That's just meant to kind of confuse you into thinking that you have to match it up to a certain genotype like we did in the females. So whatever sex it's not in, they always have to tell you what their genotype is, or they might tell you the parent's genotype or something like that. So you can determine his genotype. So in this case, I tell you he's homozygous dominant. Great, super easy. And this is a male, so we have to include his sex there. Okay, now let's look at the crosses. So remember, we're going to take our A's to the side in one little cross and our X's and Y's to the side in another cross. So if we cross homozygous dominant with homozygous recessive, all of them would be heterozygous. If we cross XX with XY, you'd have half females and half males. So now looking at the offspring, I'm going to split this up into females and males for offspring. Okay, so for females, if we know that she's female, that means that she must be heterozygous for that big A little a, since that's her only option. And this means if we look to our female side over here, that means heterozygous, she has spikes. The males also, if we know they're male, their only option for the A gene is also heterozygous. So now I look to the male side of my chart right here, and I see heterozygous equals no spikes. So notice again, just like in sex influence, the same exact genotype is different based on what sex they are. So in females, heterozygous is spikes, and in males, heterozygous is no spikes. So I want you to notice something here. Where did these spikes in the female come from? Because we know she has spikes because of this dominant A. Where did that dominant A come from? Well, if you look back at our cross, it came from dad. Dad had no spikes. So even though the male doesn't express the trait himself, he can send that dominant allele onto his daughter still, and the daughter can express it. So this is what we talked about earlier with the tampon example. The male can carry the tampon and pass it on to his daughter, and the daughter will use it, but the male never did. Same idea here. The guy had the dominant trait. He had no spikes. He couldn't use it, but he is able to pass it on to his daughters, and his daughters can use it. So this shows that males can still influence what their daughters look like. All right, and that's sex-limited traits. So make sure that you understand this, and you also see the difference between this and sex-influenced, as well as noticing how both of them are different than sex-linked in Chapter 4. All right, so that's the end of that video, and the next one will be over genetic maternal effect.
I hope you found this video really helpful. The concepts and information presented in these videos will be true no matter what genetics class you are taking. However, the concepts presented in this video are referencing material currently covered in Baylor University's coursework. Remember, if you are currently enrolled as a Baylor student, we offer free tutoring services. Our tutoring center is located on the first floor of the Sid Richardson building. You will find all the details you need to know about these services on our website, www.baylor.edu/tutoring. You may schedule a free 30-minute one-on-one tutoring session online through Navigate, or just drop in during our open business hours. For more information about our current services, please visit our website. Thank you.